Thank you everyone for being here. I'm with Jistro, he's the CTO, also the EVVM. Both of us are the architects. He's also the core developer. So we are presenting the EVVM, the Ethereum virtual machine. It's a virtualized layer. It's a new concept that we are going to show you. I don't know, can we start? It's fine, okay. So the time. Well, first of all, you can go to evvm.org to check documentation, to check another presentation we made. And we are going to be in ETHCluj in France on July 2nd, also presenting and doing a live demo. Through the slides, you are going to see QR codes. Each QR code will drive you to a special part of the repo, of the documentation that will let you get more information about what are we talking about. So first of all, the state of Ethereum now in 2025 is L1, and there is many L2s, there is L3s or other mainnets is the same, there is subnets, there is app chains and all this new infra that is added to add scalability with new functionalities. We think that this is solving somehow the problem by approaching by different technologies, but what happened historically in the internet space for scalability and for have more availability is to go, in example, from dedicated servers to virtual private servers to the cloud. So what we are approaching is something like that. So we are solving chain fragmentation and scalability with an infra-less solution. What this means, we are pushing for vertical scalability. This means that with the EVVM, that is a set of smart contracts that is about 60K lines of solidity, you will be able to deploy a virtualized layer, a virtualized EVM in this case, into an existing EVM. So this is a virtualized blockchain where you don't need to add infra. You will have an abstracted layer where you will see, well, please check the docs, this will be available online also. You will have the possibility to create a lot of new functionalities there, as it is an app chain, a layer 2, a layer 3, attached to this L1, or you can deploy also in an L2. So what is already implemented in the EVVM that is very interesting is dispersed transactions. You can put hundreds of transactions inside one that will be executed for that transaction specifically as one. You can have executors that you will see in the demo that we are going to show you, where you can give a voucher to someone else to execute your transactions, but in your behalf. So this is very good for paying expenses, to use AA agents or other functionalities that you want just to have someone else to execute it in place of yourself. You have tokens whitelisting, so you can choose which tokens can interact inside this environment on the EVVM that is deployed on an EVM as a contract. You have also a natively named service that is full working, that works with names, that resolves on the EVVM if you want to use it in place of addresses. And also, we are working on the capability that is almost there to have phones and emails also working natively on the EVVM. It's important to tell at this point that the EVVM is an open source project that you can use for free for personal use and educational purposes, not for commercial use, but you are free to install it, to fork it, to deploy it, and to do your modifications under the license. So you also can have native tokens that are different from the native tokens of the EVM that you are deployed and will be respected as native tokens in the EVVM and will behave like that. You have staking rewards. You also have async nonces. This is very interesting. You can have synchronous nonces that happens usually in the blockchains, and also async nonces working at the same time for every external loading account. And you have trusted execution environments relayers also implemented there. That is very interesting for DeFi functionalities. So security, your own execution environment rules, You can make it permissionless or permissionless. As you see, there is the EVVM, and the EVVM is demilitarized into the EVM or not. You create these zones, as happens with the routers and these kind of implementations. And you can tell who can interact with the EVVM and who cannot interact in the EVVM. So you can make it open or you can make it closed. There is abstraction. Everything is abstracted inside the EVVM. So you abstract transactions that are into the payloads of the intents that goes into the EVVM. This works in a everywhere intent structure, unless you want to go permissionless to the EVVM as a user, and you can go, or you go with intents through a fisher or relayer. We call them fishers because on the conception, we were using all the mempools of all the blockchains for doing transactions into the EVVMs. How? We configure very low gas fees on the transactions, so never going to be processed on the blockchains that we were using, leeching the mempool, and there was fishers like fishing these transactions because they recognize it, take it, and relay to the EVVM environment. So we also have abstraction nonces, native tokens, OPCODES. So this is more or less how's the structure. This is the EVM. The EVVM deployed inside. A user can go permissionless or can go through a relayer that also can be a T. So there is also a yield generation protocol inside that is working with Aave. And what it does is every time you want to interact with the meta protocol, that is the EVVM that we made like the model, but this doesn't matter, could be your own EVVM. You will synthesize the tokens that are deposited there as collateral. So if you want to have USDC into your own EVVM, you will request the user to send this USDC to the EVVM through a contact address in any destination chain and make there a bridge. You can use Hyperlink, CCIP, XLR, anyone. Or you can go maybe directly transfer this USDC to the EVVM if you code what is needed for the adapter, but it's very easy. And you will synthesize this USDC inside. But what are you going to do with this USDC, with this ETH, Bitcoin, whatever? You can use it on the 5 protocols while it's being used inside the EVVM and generate yield. With this yield, you can earn money if it's your purpose and inside is a game or something, or you can reward all the actors that are making the EVVM work, like in example relayers, and you will give rewards to the relayers by doing good actions like executing transactions from the users for free. And you will reward them with tokens that they need to stake, and with the stake you will estimate how much is for each relayer every month, and you will give them yield from what was deposited there. This is already coded and is already available. So now we can talk about service. What is a service? A service is something that is working around the EVVM. In example, we have peer-to-peer swaps. We have loans from Aave. We have the name service. These are services that are all around the EVVM as smart contracts. With these services, you can interact with the EVVM. You can give more extended functionality to the users, and the services get rewards for using the EVVM. You can see also in the QR code. And, well, it's great to use as a sandbox. If you have an EIP, you can just code it into the EVVM, deploy it, and ask all the devs and the users to start using it, and you will get a lot of feedback. You can do the iteration of disable, deploy again, upgrade, whatever, until you are satisfied with the results, and then you can upgrade the EVM of your preference. Like an example, I know, Mainnet. So what we see, maybe the future of blockchain can happen in just one mainnet. The security is enough. So what we are pushing is having like an EVVM for art, maybe, EVVM for DeFi. Uniswap can deploy their EVVM in place of deploying a new chain. And like this. And this is a question, is have you ever seen a Web3 hyperstructure? This is a reading, it's an article very interesting that you can check for later. Web3 is for hyperstructures. This means, well, there is all the explanations, a lot of concepts, and I invite you to read it. And please join our Telegram devs group on the left and mint the official POAP on the right. And well, now Kevin will show you a demo, how this is very easy to use.
So let me load the demo. Okay, perfect. I'm gonna be a little bit quick, just for the time. So we begin the transaction. So we have the signature construction example. We can stop for this part. This part you use ERC-191 to construct all the signatures inside the EVVM, because all the executions are inside. Try to configure it, and well, for the single payment for this example, we're gonna use. We can continue. I gotta connect the wallet and. So for this, we're going to implement the address to send it. And this part, the single payment signature structure, we can stop here. Perfect. We had a concat of what type of execution we want. If we want synchronous or asynchronous nonce. We had the receiver address, the token address, the amount, the priority fee, we're going to talk about later, the nonce, and the priority boolean and executor. Also, we're going to talk about later. So with this, I can continue. We can form that signature. So using our template, we can find on the devs Telegram group. We can form the address or even a username. So if we remember, the username can be just a username, email address, or even a phone number. We're gonna generate a nonce and token address and an amount and a priority fee. And for the execution, it's very, very easy. It's like a voucher. So maybe for an AI agent, maybe you wanna execute inside the EVVM, you can select the address of that AI agent and send the transaction to be executed inside the EVVM. So after that, we had all the data we need to execute. But because it's a testnet, we need to get tokens. So inside the contract, we had the add balance function. So that add balance function, you can add all the tokens if you want, because all the tokens are, I don't remember the name, but because we had that abstract of the token, we can set any token we want in the testnet. Obviously, when the mainnet goes, you need to pass all the tokens from the bridge to the EVVM. Just forget that token amount. So when you have the faucet ready, we're gonna execute the pay no staking because we are not staking. The only difference the staking and not staking is the staking receive all the rewards and priority fee, and the non-staking doesn't receive anything. So we're gonna add all the data, the from, the address to send the amount. We're gonna get the identity clean because we're gonna use the identity, the token, the amount, the priority fee, and the nonce. We use ERC-191 because it's untempered. That means that any value, or if you wanna do twice the nonce, obviously the transaction fails and you can do nothing with this. So you need to get the equal data from the signatures and the transaction. So right now, we executed the transaction, and we're gonna see the balance for that address obviously with the token, in this case is Ether, is address 0, and the Mate token is address 1, and we get the amount out transfer for this account. But maybe you can say, okay, it's good, but I want to get certain amount of tokens to certain amount of addresses. We can do that with Disperse Pay. Just maybe you're gonna send a USDC to all your friends, or maybe a DeFi protocol, or various DeFi protocols. You can do that, or even with Pay data. Well, can go back to the last one. Yeah, perfect. With Pay Multiple, we can send various pay transactions inside the EVVM all at once. That means if maybe you wanna send some transactions to a DeFi protocol, or maybe various agents, or maybe you wanna execute because you are a fisher, you can do that all at once.
Well, thank you. That's our presentation about the EVVM. We have some minutes left for questions.
Yes, that was a powerful introduction of everything. No, keep it. So yes, we're actually a little bit ahead of time. So please, do scan so we can ask the questions for, are you talking to me and Jistro? So will the EVVM native tokens be public available or strictly related to the EVVM's namespace?
Well, the EVVM is a concept itself, so this depends on the configuration of the deployer. So in our case, for the Mate meta protocol, that is what you can read in the documentation because it's the first example, it's not separated yet. We will make them available only within the space of the EVVM, so there will not be a contract outside the EVVM for the native token, that is Mate, but you can make it. There is no problem or any restrictions to do that. It's just about configurations. It's part of the novelty and gratefulness of virtualizing and abstracted everything, is that with just a few Solidity code lines, you can code opcodes emulated, you can code any configuration you might want. And the next question will be about optimization, of course, and if this is more heavy processing than do it natively on the clients. Sometimes yes, sometimes not, but this is the first approach of virtualized layers. So, of course, there is a lot more to do, but the thing is that in practice it's possible, and a good part of the EVVM is that as everything is abstracted, if you are the deployer and you set up the rules, and in example, you have only 3 layers, you can fork it, disable, depreciate it from one chain, deploy it in another chain, the fork, and will continue being used without notice by the users, the banks, or the institutions, whatever. And you can migrate it from the best option always.
So are the rate limits tied to the EVM, the EVM's deployers on from InfraMaster?
Okay. No. The finalization time, yes, because you are attached to that. And that's why in the previous question, I also told about the fork and move the EVVM within the ecosystem. Because if you are not convinced about the rate, that finalization rate, that is most important that block, I think, in this question, because blocks are happening very often now. You can move it away, but remember that you can encode or incept more than one transaction, like 20, 100, 200 transactions in one transaction, so you will be multiplying the capacity of any chain that you are deploying on.
So I see there's a little bit of hallucination in everything. This is questions that came in from the beginning. But my personal question to you is, how did you actually come up with a concept of an EVVM inside an EVM?
Well, the thing is that back in time in 2023, in Waterloo, we were at ETHCluj Hackathon, and we invented something that is called Rolamate. In rolamate.io, you can check it. There is the live demo. that was a gasless payment solution for Ethereum mainnet. And how we did it is we started using the mempool of Ethereum mainnet to configure transactions, reducing nonce, and use it as a communication protocol with validation of signatures. And we were listening to this mempool with relayers that we coded and executed them on Gnosis. And in Gnosis, we had only an order book. So after winning the hackathon, we were requested by some enterprises to make this happen and be something real. So we started to figure out the architecture to make this scalable, usable, secure, and all these things. And we realized that we need something like the EVVM to make this robust enough and secure enough. And well, so the EVVM was not the product, but was needed for the product. So at the end of the day, we finished with the product that is the EVVM, and the payment protocol is a secondary product that is mounted on the EVVM. So this happens just because wasn't our objective. I mean, it's a way to fund the startups and also to build a company is try to go with the needs and not just following your own idea.
Well, personally, that's why I love hackathons, because you find the most amazing things. Do we have any questions directly from the audience? If you don't want to use the app, we can always come down to you with a microphone. Nobody have a burning question? There we go.
So I have a question. How easy is it to add new opcodes which are added to EVM or precompiles or other native support?
Okay, for that, testing of opcodes is just a proxy. I like to call this because they try to figure it out how to solve this. So with that proxy, we call it as it is, you can hard code it all the proposals to make that is the opcode. I don't know if this solves your question, or maybe.
I'm not sure I completely understood that. So you said you can hard code the specific opcode?
You can code it, not hard code it, but you can implement that opcode and simulate it inside the EVVM just for testing out the input and output of that opcode.
Okay, so for example, if I need to use a new opcode, do I need to use for your protocol upgrade, or can I implement it myself? How would that work?
Okay, first we implement that kind of proxy. So you need to first upload your opcode inside the blockchain you want to use the EVVM. And after that, you link that opcode with the EVVM, and you can execute that function related to that opcode.
Okay.
Or if you don't want to give that deep, as Kevin said, you can just code it in Solidity as an emulation and check how it behaves. And that's a good part, because in the EVVM, the interface is the interface of the smart contract. It's like acting like the RPC. In the EVM, the RPC is the interface to interact to the EVM, because it's where you enter with the transactions. In the EVVM, you enter through the interface directly. You are already on chain. So there you can emulate a lot of things as well, a lot of functionalities. You can call like simulated opcodes. And as you have all this EVM environment that is emulated, it's more easy to you to connect things and try to have a normal behavior than having just a smart contract with your opcode alone there floating like that.
So perfect. So let's get the last question. We have just one that came in from GasGosler87. Could EVM simplify or even replace roll-up architectures in the future, given its ability to abstract gas tokens?
Okay, this question is a little bit spicy. So when we talk about rollups, most of the rollups apps like Uniswap or maybe Workcoin, etc., etc. They have that community can implement nodes inside, but when we try to use for enterprise solutions like banks or maybe import and export for certain areas, they want to make that nodes private as possible, or even doesn't use any nodes for that. So with this kind of solution of the EVVM, you can make your own infrastructure without using any node system or take care of that protocol. So you can implement the EVVM inside of the blockchain of your wish, maybe a public chain, or maybe a L2 or L3. And yeah, you can simplify that rollout without any problem.
Perfect. I hope everybody got their questions answered.
Okay.
So next up, we're gonna have a little bit panel coming up, and I want to thank you. Ariutokintumi and Jistro. It was nice to Jistro. Sorry.
Thank you for your presentation and be here.
It was lovely to have you. So
Thank
meet them
you.
outside and have a good talk with them. Let's give them a hand.